In this video we shall talk about such nice and useful thing as indexes. In DBMS, an index is a special construct that helps us to improve the speed of access to data that physically is stored in some table file. Comparing to real life, index is a kind of map for a human that helps us to find objects of interest quickly and easy. As everything in this world, indexes have something good and bad. Let's start with good. Okay, indexes are rather small, enough small to fit the RAM, to access them extremely quick. That's good. Index structure is optimized for search operations. We shall discuss that structures in the next video. And indexes may dramatically increase search speed. We shall see it in a couple of seconds. The bad things are the following. Of course, indexes may fit the RAM, but they may take a lot of that RAM, so you should probably not create too much indexes. And indexes should be updated after data modification, and that update process may take significant time. So once again, think carefully in order not to create unnecessary indexes. So, when to use indexes? The first idea is to use indexes when read operations on a table are performed much more often than modification, because, as we remember, modification of data leads to modification of index, and read operations do not lead to modification of indexes. So if read operations prevail, you can easily create rather a lot of indexes. The second idea is to create indexes on that field or those fields mentioned in where clause. It's useless to create indexes that are not used for search operation. The next obvious idea is that if an experiment shows that the presence of an index improves query performance, you should use that index. If some experiment shows that there is no speed increase or maybe even a speed decrease, you should probably eliminate that index. The next two ideas are technical ones. You should use index for field values uniqueness purpose. Because when we have a lot of values, unique values, and we add another value, the DBMS should check that value against everything that's already in the table. So here the index will help DBMS to increase the speed of that operation. And when you make a relationship between relations, you should put an index on a foreign key. Because when we have parent relation and child relation, we have primary key here and foreign key here, and we usually use something like join SQL query to connect those relations. And of course, DBMS should check if a primary key value is equal to some foreign key value. So it should search through primary key that is always already indexed, and it should search through foreign key, and making an index on the foreign key may increase join operations speed drastically. Let's see a quick demo. Imagine that we have the following table, news, with no indexes except for the primary key. So this field is already indexed. And we have a news identifier here, rubric, date, time, title, annotation, author, text, source, and maybe some other fields, but that's all for now. And let's see what we can do with indexes here. On the first attempt, we shall execute the following queries 1,000 times each. We shall insert 1,000 records by 1,000 times, so we have 1,000,000 records here in the end, and then we shall select something from that table, searching by news rubric and date time of publication range, then by date time and publication range only, then by title and date time publication range, then by title, publication, date time range and author, then only by title and author, only by title and only by author. The absolute time values doesn't matter here, but let's us just remember that we have about 0.03 seconds for insert operation and about 4 seconds for each select query. And now let's create several indexes. Simple index on nRubric field and compound indexes on nRubric and datetime and title and datetime and author. And here is the question for you. One of these indexes is redundant. Which is and why? Look carefully here at these indexes, pause the video and try to make out it yourself. Which index is redundant here? The answer, of course, is that this one is redundant, because as we remember, with compound indexes, the DBMS may use the first only field as a single field for search operations. So as long as this field is the first here, we need no such separate index. And here's our second attempt. Again, each query for 1000 times, 1000 inserts, and those the same selects here. Now we may compare the results. Let's start with select time. We have about 0.0 here and 0.9 here. So about 30 times of speed decrease. Okay, that's bad. But let us analyze these values. For instance, let us see at this. We have about 4 seconds here and about 0.0002 here. That's extremely good. So a lot of those indexes mentioned on the previous slide are extremely good for such operations. There are a lot of index types and we shall discuss them in the next video, but now we shall see how to create an index. With an SQL query is the obvious approach. Here's the code for table creation, and here are code samples for creation of compound index and simple indexes. And this is the schema for the result. If we want to create a unique index, it has to make a field unique one with unique values. We shall use the following approach. Here's the code for table creation, and this is the code for index creation or unique constraint creation. We altering the table, adding constraint, and we say that this is unique by that field and in ascending order, or it may be in descending order in some cases if we prefer that. Once again, this is all about index types, index differences, index varieties. And of course, we may use some special tool, in our case Sparx Enterprise Architect, and we shall see now how to do that. Imagine we have such two tables, books and users, and we want to create some indexes. First of all, we want to create some index on book name. We shall right-click, Features, Constraints, Indexes. We shall start index name with IDX prefix, and usually this prefix is followed by the indexed field name, b name here. Okay, it's indexed by default, and the only thing left is double-click appropriate field. So here it is, close, and we see the index was created. The next we want to create a compound index on B quantity and B year fields, making B quantity the first field in that index. Once again, right-click, Features, Constraints, Indexes, IDX, B quantity, B year. Yes, it's index by default, and double-click B quantity, double-click B year. Close. Here it is. Everything's done. Then we want to create a unique index. Remember that logins should be unique, for instance. Right-click, Features, Constraints, Indexes. Here we shall start with UNQ prefix, making it clear that this is unique constraint. ULogin. We shall switch from index to unique here and double-click ULogin field. Close. Here it is. Everything's done. But how can we know if an index is really useful without making some experiments? We may use SQL query or maybe some special tools to see the query plan explanation. We shall review it for several DBMSs. In MySQL, all you have to do is add this explain word before your query, and you'll have such similar to this result. What we need here is those three fields: possible keys, key, and key len. Don't be confused, because key and index are synonyms for MySQL. We can see that here no indexes, no keys are possible, so no keys, no indexes were used with no length at all. But maybe if there were some indexes or in some other situation, we would see something useful here. Please refer to the official documentation of MySQL and any other DBMS. In Microsoft SQL Server, we may execute a query using Ctrl and L key combination, and we shall see such a nice graphical schema. We may see some indexes mentioned here, some relative costs, some other information. So once again, if you are using Microsoft SQL Server, read carefully that documentation and find out everything about query explanation and indexes in that DBMS. If you use Oracle, you may use the following approach. You have to put explain plan for, then your SQL query here, and then you may see the result of that plan calculation. Once again, some indexes are mentioned here with some information about them, and so on, and so on, and so on. There is a lot of technical information. So once again, please refer to the official documentation of that DBMS in particular, or any other DBMS you are using. And in the next video, we shall review indexes types.